I mean, I think I used to ask you this last time, but
Yeah.
what is it? What will be useful? Um, like, what are the use? Is it just that you want to figure out what happened to the antimatter, or is it like there are practical uses to like this neutrino stuff? Is it like there
Um,
could be like neutrino is because like neutrinos don't interact with stuff, right? Or a lot of the time, they're kind of really small and
yeah, yeah,
stuff.
yeah, yeah. I mean, they don't. I think. I mean, neutrinos are like very kind of strange and interesting particles because their mass is so tiny. They can oscillate between different flavors of themselves. And finding out more about them basically might eventually lead to us being able to use them in technology in a way that we just can't now because we don't really they're they just they're just they're just so hard to kind of detect, and they're so hard to use in like to use in technology because we don't have much control over them, I guess. you
Mm,
know
mm.
um, so I think finding out more about them will basically maybe give us the potential to implement them in some kind of technologies one day. Perhaps. I mean, that's just
Cool.
theory.
Kind of like some new instead of electricity, like some new on some neutrino
Yeah,
electricity, whatever, like which is like faster and I don't know. I mean, I can see some. I guess I can understand that side of things. It's
yeah, and I think everybody at this time uses the kind of the electron analogy, which is when the electron was discovered, it wasn't completely clear what we would do with it.
yeah,
Um, and now we obviously run the whole world on electronics.
yeah, yeah.
And so, finding out more about the particles that exist and how they behave, obviously, I think will lead to ideas about how to harness them in technology and,
Well, you've also
in
got
art.
like yeah, because you've also got like within obviously to do with light and stuff. You've got like fiber optic cables and all of these things.
Yeah, exactly. Yeah,
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 so
sure.
it's yeah,
Transmission of information. People are
exactly. Yeah,
moving on to quantum information now.
yeah, yeah.
Quantum technologies to transmit, to do calculations. Seems to be really powerful. But this is all coming from finding out more about particles and what their properties are.
So within the because I think yeah, with CERN and stuff, it was always about scale and this thing being massive and the speed of things having to be really high and stuff like that. What in terms of like the speed you talked about 1,000 was it was it a mile underground? It's like a
Yeah,
yeah, over 1,000 meters, right? A bit
yeah,
more than
1,600 meters. Yeah.
so you've got like very deep underground. In terms of the speed at which things are going, do you know kind of what kind of speeds these things are going at?
What, the neutrinos?
Yeah, I mean, they're going to be firing um protons. You said so. Is it like high energy collisions? Is it like kind of
Yeah.
dangerous like before
Oh
with the
no, no, not
CERN
really.
stuff?
I mean, I don't think it was ever dangerous, to be honest.
Well, it's just because of the massive collisions.
Yeah, yeah. But I mean, neutrinos go through your body all the time.
Yeah, yeah,
They come in from the sun continuously, and so there's a huge influx of solar neutrinos at the through the Earth, and so I think the yeah the there are the risks are absolutely minimal. They don't exist really. But that's it's always like it's just one of the reasons that we make sure we educate the public on this. It's just so they know this, because
yeah.
obviously if you hear it, you might think, oh, there's all these particles at high energy, but this is like not in any way kind of
What sort of speeds? Is it like do neutrinos always travel at the same speed, or is it that you can
I mean they'll
accelerate?
they'll travel close to the speed of light.
Okay, cool.
Um, So, yeah,
Is it,
you know,
are some like faster than others, for example? Is that kind of how it works, or is it?
I mean, not really. I think, you know, their mass is quite, because their mass is so tiny, they're going to travel very close to the speed of light. But I think they, you know, to first order, they're all basically going at the same speed.
Okay, cool.
Yeah.
Okay. And in terms of how many neutrinos, do you know, like, is there like a per second, how many millions? Because again, it was like with your collisions per second in CERN, there was like loads, and then the data and stuff.
Yeah, that's a good question. I mean, it's a different type of detector because we're trying to, we still need to think about like the bandwidth to read out such a large detector.
Yeah,
Um,
okay.
but it's also not like we have like 100,000 collisions or 40 million collisions like at the LHC just happening all the time.
Yeah,
But
yes.
again, I need to get a number for you on that, which I don't have at the moment.
Okay,
But
cool.
I could find that. Yeah.